Well, hello there. My name is JJ Asghar, and I'm a developer advocate for the IBM Cloud. You're here to see a simple Python application deployed to OpenShift or Kubernetes, and I'm going to walk you through it during this talk. I'm going to start with some slides first, just to kind of make sure that we all have the same language and vernacular. And then from there, I'm going to go into the demo as quickly as possible. And hopefully you'll see how easy it is to be able to just get a very simple application, a simple Python application deployed to OpenShift specifically. All this stuff you can take and run with it yourself, and hopefully you'll see how easy it is. And let's see if we can do this under 20 minutes from soup to nuts. This will be fun. Come on. All right, hopefully you can see OpenShift and Kubernetes in way too short of a time. Again, hi, JJ, developer advocate, and I really do have the email address of awesome@ibm.com. You can find me on Twitter @JJAsghar. If you ever have any questions or if I can help in any way, never hesitate to reach out. My job is to be a personable nerd to be able to help you get the information you need. So let's start with some building blocks first. We need to start somewhere. So in order for us to understand the advantage of using containerization or Kubernetes or OpenShift for that matter, we need to build something. We build it up from a foundation. So let's start there. Everything that's inside of the container ecosystem is built off of something called a container, hence the term. There's two major different players in the space right now, one called Podman from Red Hat, and the other one called Docker. Unfortunately, my marketing people informed me I'm not allowed to use the Docker logo due to branding rules, so of course it's an old man yelling at the cloud. There's multiple offerings, Docker, Builda, Podman, there's Canico. There are different ways of doing it. They all adhere to something called the OCI spec. They all need a registry of some place to be able to actually put the container and hold it. And everything's built from something called a Docker file, which is a souped up bash script in all seriousness. And then finally, as long as it adheres to the OCI spec, you can package it and run it anywhere with the container runtime. So that whole promise of a developer saying, hey, it worked on my laptop, if they containerize it and send it off to the QA or production, as long as they're adhering to the container spec, OCI spec, everything will work. As you start getting more advanced into the container system, you need some way to orchestrate all of them. If you actually look at what Kubernetes is, it is a very, very stripped down way to specifically just run a container or orchestrate running containers. There are obviously companies like IBM that will allow you to run Kubernetes on our systems. We have an offering called IKS or IBM Kubernetes Service, but it is actually just community supported. So the actual underlying system of Kubernetes is open source, is run by the community, and there is no company behind it. It is just a project. The framework is so small that it's designed and scoped specifically to run containers and orchestrate them across a bunch of different stuff. And we'll get into that in a minute. The platform or the user is responsible to integrate more than just the core. So if you need security on top of it, you need other different systems. You actually have to do the work to be able to make that happen. That's the reason why you see things like A3S out there or other different systems that have built-in bits and pieces. And that brings us to the actual enterprise offering of OpenShift. What OpenShift is a containerization built on top of Kubernetes with the production grade, actual enterprise ready Kubernetes for your system. That's actually a lie. It's actually 4.8 now. There's actual enterprise support behind it, which is one of the coolest parts about it. So you actually do get the Red Hat 10-year support with OpenShift. There is the best of breed of choice, where it is an opinionated groupings of systems around Kubernetes. But the beauty of it is you actually get the support to run your business on it. There are some strong opinions inside of it, but if you go whole hog into the OpenShift ecosystem, your developers will, which you will see here in a moment, your developers will be able to have the environment that they need to run the containerized applications. This is really important because it's no longer you have to build it. You get to just, in essence, buy it and be able to get your business out the door instead of you spending the time and effort to being able to, what's a good word for it? build what you need. It's very much a conversation that you need to have with your teams and your understanding that if you are going into this ecosystem, the advantage of leveraging something where it's already supported and everybody knows about it, instead of you building up bits and pieces of what you need, if that makes sense. So I actually lied at the very beginning of this. The inside of the Kubernetes ecosystem, and by the way, I'll use Kubernetes and OpenShift interchangeably. I will mention specifically when it's an OpenShift difference, but if I say Kubernetes, it works on OpenShift, and then I'll specifically say OpenShift when it works on just OpenShift, or the layer of OpenShift. But I actually lied at the very beginning of this. So most people, when I said everything's built off of something like a container, that's not actually 100% true when it comes to Kubernetes. As you see here, Kubernetes and OpenShift at the bottom, the actual smallest thing it knows about is something called a deployment. And as you can see here, there's 3 different deployments going on, where you have a deployment replica of 2, where it will make sure that those 2 pods, which is a grouping of n number of containers, is always running. And then the deployments in pod B and E will always be running somewhere in the cluster too. So you tell Kubernetes, hey, I need a deployment replica of 2 pod A, it will find a place and go to hell and back for you to make sure that it is running, which is important to know. So the smallest thing that Kubernetes knows about is actually a pod. It's not a container. Another important thing to mention is nodes. Nodes are actually the compute of Kubernetes or OpenShift. And when you talk to it, you talk to the API, and Kubernetes figures out where to run the thing. So even though we have 3 nodes here, to us, as the downstream user, Kubernetes and OpenShift is just one big blob. That's important to know. And a good thing to kind of, anchor your thought around Kubernetes or OpenShift is all it is just an API to compute. If you anchor your thoughts and kind of build up your knowledge around that simple concept where all Kubernetes is an API to compute, everything else kind of just falls into place. I've trained Kubernetes to quite a few people now, and after discovering that, after speaking to some people about it, it really does make sense, because that's what you do. You give it a declaration of how many containers inside of a pod you want to run, and it will do the job to make sure that it happens. The storage and all that stuff is all around it, but the core aspect of Kubernetes is it's an API to compute. So again, you can actually have affinity rules and anti-affinity rules for specific nodes. Say, for instance, you're doing some ML or graphics work. You can make sure that the nodes have specifically a graphics card in it or whatever. But that's a little bit out of scope for this conversation. For what we are trying to understand is that we have this API that takes a container and just runs. And I apologize that I keep looking off over to the side here. My screen is a little bit weird, so I'm trying to share at the same time, so I'm looking, but hopefully it makes sense. I am more than aware of sometimes my views here. Anyway, let's keep going. So let's talk about some internal concepts and of Kubernetes and OpenShift to kind of make sure that when I start playing around with it live here in a second, you kind of get the reference points. Of course, because you have no idea what's actually inside the system or what the names of the pods are, you need some way to name them. And of course, what do all engineers go for in the web? DNS. Of course, we have our own DNS inside of Kubernetes. It's called kubedns, and it does service discovery for you. So you can service a name called foo web and map it to machine or pods. For instance, this pod C here, and label it to make sure that whenever pod A internally inside the cluster is looking for foo web, it knows where to go. Now, that's not 100% true now. You have ways to be able to extend the services outside the cluster into like other offerings like Route 53 or different external DNS providers. But for our conversation, kubedns is just internal, and it's a way for the interpods to talk to one another, so they don't have to know about each one. And if a pod dies or whatever, it knows to go to the labeled way, and the desired state actually gets to the machine. It's much more complex than that, but for our understanding, that's more or less what we need to know. The next thing you need to know about is something called namespaces. Namespaces are extremely powerful inside of Kubernetes. And as you notice here, we have 2 namespaces, my application and your application. They're exactly the same. They have a service and 2 pods, and they just talk to each other, or talk internally inside the namespace. This is very important to know. This is the way you can slice and dice your Kubernetes cluster up into your application, my application, or for that matter, dev, QA, and prod. So you can actually run dev, QA, and prod all in the same cluster, and they cannot talk to one another. Okay, now that's a little bit of a lie. There are ways to cross namespaces, but out of the scope of the purity of this talk, that's not possible. It's a way to be able to slice and dice your Kubernetes cluster. So then now all of a sudden, you don't have to worry about Jane Doe's computer underneath her desk to run UAT. Now you can actually run it on the actual hardware that your Kubernetes cluster is running. This allows you to do real performance testing, and there's actually huge benefits around it. So it's well worth spending your time looking into this. Okay, so now with namespaces, the next thing, and this is specifically to OpenShift, something called projects. Projects extend the namespace ecosystem into some really interesting isolated layers on top of it. It adds real RBAC to it. So if you have, for instance, Active Directory, you can actually tie your specific name or specific projects to different AD groups. So your devs can only get into payment dev, for instance, or your payment prod can only get to your DevOps people or whatever. And they are completely isolated on top of it. Projects really are insanely powerful. Also, with the use the workflow of OpenShift specifically, and this is an OpenShift specific thing, you can actually leverage projects to be just like feature branches with using Git. So if you use Git with feature branches, you can create a project as easy as you do as a Git branch, push your code inside of it, have it be able to reach the things it need to, see that it works, then merge that back into your main branch and delete that project basically ephemerally, which allows for specifically developers to be able to really use the same kind of tooling and understanding that they do for their job on an interface that makes sense. Projects really are something that really do like just ramp up the OpenShift ecosystem to help developers be successful. So we've talked about kind of like internally what's going on inside of the cluster. Now we need to talk about how to actually get into it. And that's where there's a couple different ways of doing it. The first one by default, or actually not by default, but the one that people mainly go to for Kubernetes is something called a load balancer. It's just like an F5 load balancer. You can actually rip out the load balancer and put in other load balancers now. It takes input from an external IP and level sets around the pods that are required. You can actually have a whole talk just on load balancing alone. If you're a networking nerd like I used to be, you can go down that rabbit hole for a very long time. But there's all these knobs and dials you can switch, flip around to play with. I would strongly suggest doing your own homework to see how it fits for your application. The hardest thing in Kubernetes is something to understand about something called an ingress. An ingress, this is actually the way you, in Kubernetes, map all your pods to the different services and how things come in. Now, it's becomes a really massive YAML file, as you see here in the example on the far left under ingress there. And that's a very simple example where it maps the external / path to foo web, and then if it needs to ever hit data, it finds the service for data and then goes to port 3000 on those pods. That's it. And that's pretty nice. So it's a way to really map out how your microservice-based architecture fits inside of Kubernetes. But the problem is it's very static. So anytime you need to add a new pod or anytime you need to move something, you have to edit the ingress, and it becomes very tedious. And imagine you have 30, 40 different services. This YAML file gets massive, and it's really, really, really unruly to deal with. So you have to really pay attention to this. And that's one reason why inside of OpenShift, they have something called routes. Routes actually extend the ingress, so you don't have to worry about it. And it is really just simply 2 commands that you run, and it deals with that YAML file for you. It takes the challenge of of ingress and having to deal with it manually, and turn it into an interface that you can just flip things on, flip things off very easily, so you can play around and get the things you need done quickly. We're going to play with a route or two during my demo, just to kind of show you the advantage of it, and then we'll kind of go from there. So I'm going to talk about some things in the ecosystem, just to make sure that if you do see these pop up as you go down this journey, you at least have some form of reference, and it's not just gobbledygook, I can't say words. And then you can be able to kind of work from there. The first thing you need to talk about is Helm. You'll see Helm all over the place. Helm has become the de facto way to install applications to OpenShift and Kubernetes, even though the OpenShift ecosystem is moving to something called operators, and that's a much larger conversation. But when you see Helm, think of Helm as just a package manager, a way to programmatically install a bunch of things inside of Kubernetes or OpenShift and just kind of get them on there. GitLab is a perfect example of it. If you want your own GitLab instance, there's a Helm chart to install, and Helm takes care of the lion's share of the work for you. So you have to worry about databases and things like that. So it's very powerful, and it's a very interesting project. So take some time and do some research there. Next, we have Istio. Istio is, in essence, the service mesh. Service mesh can be its own conference. I'm not going to go into that, but this is a way to be able to intelligently talk to and work around the containers inside of your Kubernetes cluster or OpenShift cluster. It allows you to have secure communication. You can actually trace communication between the containers, which is really neat. There are two major players, Istio, and the other one's called Linkerd. I think it's Linkerd 2 now. And Istio is kind of like the everything in kitchen sink, where Linkerd is just what you need to run the service mesh. Two very different worlds. IBM is leaned very heavily into Istio, and we have a lot of really smart people working on Istio all the time. So hence the reason why that I'm showing this one off. Again, it's one of those things that you'll eventually get to inside of the Kubernetes ecosystem. I strongly suggest waiting until you're much more comfortable in the ecosystem before going there, but that is what this is. And if you didn't know, Istio is Greek for sail. I learned that recently myself. And finally, the next thing we're going to talk about is Knative. Knative is, in essence, the serverless platform on top of Kubernetes. So you might have heard of Lambda or Code Engine from IBM. And Knative is a way to run those types of scaled down to zero infrastructures on top of your Kubernetes cluster. So if you are hosting your own Kubernetes cluster for whatever reason, you can layer Knative on top of it and get the power of scale down to zero, which saves you a lot of resources into your cluster. There's a lot more there, but it's good to know Knative is serverless. Okay, so now that we've talked about that ecosystem and we've kind of talked about all the different things, let's actually get something deployed to OpenShift. So I'm going to go ahead and turn this off. And I'm going to shrink that. So first thing first is here is my amazing application. I'm trying to make this bigger, and I don't know why it's not. View. Zoom in. All right, there we go. Oh, that's probably too big. There we go. This is actually on GitHub. JJ Asghar, Cloud Native Python example app. And I have this amazing application, app.py. And as Python people, you know that this is pretty much the most simple thing you can ever do. I actually did this at PyJamas, and that's the reason why it's there. But as you can see here, I have a simple Flask app, and this is the worst amazing app ever, speaking in PyJamas. That's all it does. It's a simple Python application running in Flask that does this. Okay, cool. But the most important part is being able to get this to talk to, or deploying this to OpenShift. So here we go. Here is OpenShift right here. And I'm logged in as my user here. I'm as an administrator right now. I'm going to go ahead and flip over to developer. And as I was talking earlier about projects, as you can see, here are a bunch of projects inside of our application. I'm going to go ahead and create a project, and we're going to call this Conf42. And then I'm going to hit create. And while that's being created, I'm going to make this just a little bit bigger. And as you can see here now, I am on project 42 applications. I have a bunch of neat stuff here. This is me as a developer. So I am just using this as what hopefully you would be doing this as a downstream user. As you can see here, it's like, hey, you need to add something to your project. Well, one of the best things about it is you can just pull directly from Git. So I'm going to go ahead and click on this from Git repository. I'm going to go ahead and go back real quick to this URL. And I'm going to go ahead and grab this from HTTP. Oops. Over here. I'm going to go ahead and paste this URL directly in here. It validates it already and looks and reads it. And it's like, hey, check it out. It already figured out that it's a Python application. So without me even doing anything, I just said, hey, look at this repo out on the internet. Go ahead and pull and see what's going on. And it grabs it and pulls down the Python. It defaults to something called a UBI, which is a universal base image, which is basically, if you've ever heard of Alpine, it's the Red Hat version of Alpine. So everything's stripped out to be as small as it possibly can be. And it's like, hey, let's call this something. I'm going to go ahead and change this to Conf42, and then we'll go down over here to Conf42. And then we're going to create a deployment, just like I was saying earlier. That's what it needs to know about. And then it actually has this little checkbox where it's like, hey, do you need to expose this to the real world? And that's what I want to. I want to expose this public URL. I'll go ahead and create. So this kicks off. This takes a couple minutes, but we can actually watch this more or less in real time. So as you see here, it's waiting for the build. Oh, it's already, it's pending. So it's doing this just now. And it even created a service for us out of the gate. And it even opens up the URL for us too. But we need to wait for that build to happen. While that's happening, I'm going to go back over here and I'm going to show you what actually finally convinced me that OpenShift was the way of the future. And that is the built-in ways of webhooks with, oops, I was supposed to delete that before doing this demo, and I apologize for that. Here we go. So we have, we all use webhooks to talk to applications, whether it be back and forth or whatever, but you can actually have webhooks on GitHub. As you can see here, whenever any event happens, it sends a post request with that. So I'm going to go ahead and create a webhook here. I'm going to go back to our system and it should be building. There we go. It's building, which is good. I'm going to go back to our build config here. And if you see here, inside of OpenShift, they have built-in webhooks for each build config. So what I'm going to do is I'm going to copy this URL here and I'm going to paste it inside of here. And I'm going to change this to JSON. And then I'm going to create a webhook. So now, whenever I make a change to this repository, it will kick off a build on my OpenShift cluster. So if I go here to make sure it's there, recent deliveries, we got a big old red green check mark. So that's good to know. So now we know for a fact, whenever we make a change to this repository, it'll send a post to our OpenShift cluster, which allows us in essence to have continuous delivery. So anytime I merge into main in this thing, it will kick off a build, which is pretty cool. But we're not going to quite see that yet because we're going to go back to topology and we got to actually see our system work first. So as this is building, it's taking about 2 minutes. There we go. It just finished. It's pushing out the pod for us. It's thinking about it. And there's a built-in registry inside of OpenShift, which is one of the neat parts too. So you don't have to worry about like Docker Hub or Quay or whatever. It's all self-contained inside of it. So your source code stays inside of your OpenShift cluster. And it's creating that container. I'll give it a second. Put on some Jeopardy music. Patiently wait. There we go, running. As you can see, a nice little blue circle here. And I'm going to go ahead and click on this link right here. And there we go. This is the worst app ever. Speaking at PY we are not speaking there, are we not? So we're speaking at Conf42. So what I'm going to do here is I'm going to come back over to our application, and I'm going to be bad. Never do this in the real world. I'm going to go ahead and edit this one right here. And we're speaking at Conf42. 42. I keep putting 3 down. And of course, I'm going to go ahead and commit to the master branch. Don't do this in the real world. And there we go. We update that. So if we go back over here now and look at our, oh, there it is. It already had the post. It's already building it again. And if I've got my timing right, it should only take a second. We should see the pod do an intelligent restart. So it actually spins up another pod, kicks it over, and then kills the other one. You can have a liveliness checks inside of it. So if you have applications that take a while to start, you can do intelligent rollouts. So it makes sure it comes up in a good state before taking out the old one, which is important too. So you don't have any real outages for your application either. So there we go. Still running. Still running. Come on. Come on. Don't make a liar out of me. How about now? We can actually click into the view here and actually look at the logs. There we go. We are installing some packages. Why are you taking so long? Come on. There we go. All right, we're on step 10 of, I think, 12. Oh, there we go. No, it's only 10 steps. It's copying the blobs into the registry, pushing it, and then storing. There's the actual version. There we go. Now it's pushing into the registry. I'm sorry. Oh, it's another thing ahead of time. And so if we go back to our topology here, click on this. There we go. We see we are creating that new container, and we will kill this pod in a moment. Health checks, of course, are super powerful here for your applications, so your downstream users never have problems. And then, how about now? Now. Come on, computer. There we go. See, it's ran. Now it's kicked it over. So I'll go back to that URL here, and I will refresh. And there's Conf42. Wonderful. And that's it. In essence, you saw how quickly I did this. This is under 30 minutes. And what have I done? I went ahead and told you everything you need to know and wired it up together. So to make sure you see how beautiful and how awesome OpenShift is for your downstream. And I just did it through the GUI. Obviously, there's CLI commands, and there's other ways to extend it to do testing in front of it before releasing to the production environment. There's just wonderful, wonderful things. But that's just the bare minimum to understand the power of deploying to OpenShift and Kubernetes under the other side. So thanks so much. Never hesitate. Oops. There we go. That one. That's how to find me at JJ Asghar on Twitter or awesome@ibm.com. And thanks y'all for having me. Take it easy.